Hello, and welcome to 5 Minute Math. My name is Aaron Daffern, and today we are looking at the 7th grade STAAR test 2024, and we're going to learn some lessons based on difficult readiness standards. So these standards tested at less than 60% overall mastery in 2024 across the state of Texas. We will look at the items themselves, identify misconceptions, and most importantly, look at some instructional implications that we as educators can help our students do better this year. So we will start with our lowest performing readiness standard, 7.9C in reporting category 3. You'll notice that it is less than even 1/3 mastery there. We're sitting right there at 32. And it also happens to have the lowest performing item on the entire test. That 17% correct is the lowest item tested on the entire test this year. Both of these have to do with area of composite figures, and if you look a little bit more closely, both of these shapes include trapezoids. Trapezoids, outside of circles, are probably some of the most difficult shapes to find the area of, just because if we look at our formula, there's just a little bit going on there. 1/2, you have to add the two bases. So it kind of can get confused with a triangle because it's 1/2 base times height. So this is a trapezoid, 1/2, and then, both bases and the height. So let's see. This very first one is difficult because it had no A, B, C, D to choose from. They had to enter their text, so it has to be exactly correct. Probably the simplest way to look at this would be to look at it as two trapezoids. So I'm going to outline these two trapezoids here, and these are right trapezoids. Now, the typical trapezoid that students are familiar with, right, are these trapezoids that have the two slanted lines, but these are also trapezoids. And if they can recognize those as trapezoids, these are right trapezoids, this becomes a much simpler problem. So let's look at and here's the thing, there's two of them. So I'm going to double my area formula. So I'm just going to take this. What's my one base? 100. That's the short one. What's the long one? Well, the long one is the 100 plus that 30. So let's do 130. And then the height is 30. And then out of this whole thing, I want to double it because there's two of them. Now, since I'm multiplying everything, I can use order of operations. I can multiply the 2 times the 1/2, and basically it disappears because 1/2 is a reciprocal of 2. Half of 2 is 1. So this actually becomes a little bit simpler. Now I'm just going to multiply 100 plus 130, multiply that by 30. So that's going to be 230 times 30. And look, I could just multiply these larger digits. 23 times 3, right, is going to be 690. Or 23 times 30 is 690, and then I'm going to add that extra 0, 6,900. So that's these two right here. 6,900. Now there's a square left over, but it's a 30 by 30 square. That's a 900. So I just need to add 6,900 and 900, and that's going to get me 7,800. So that is our answer. Now, if I didn't recognize those as trapezoids, what I'm left with are a much different looking problem, right? So I'd have to do this rectangle, the two triangles, and then the square. You see how the opportunities for making just a simple calculation error increase with the number of shapes I'm trying to do. So on number 36 here, we also have a trapezoid. This is a more traditional trapezoid. So let's calculate this. We're going to use that same formula. So it's going to be 1/2. What's my first base is going to be this 15. Let's just take this step to both of these. So my top one is going to be 15. This longer one is the 15 plus the 3 and 3. So that's 15 plus 6 is 21. Height is 4. Now, let's go ahead and multiply the 1/2 of 4. 1/2 of 4 is 2. So it's 36 times 2, which equals 72. That's the trapezoid Now we just need an 11 by 15 rectangle. So let's do 11 by 15. It's going to be 15, 15. What do I have? 165. So if I add my 165 and 72, I get 237. So my answer here is C. So that is the correct answer for both of these. We got 47% on that. So let's look at our misconceptions. Okay. So for that first one, the text entry raised the difficulty. And they could have chosen the area for trapezoid, but that's only if they recognize those shapes as right trapezoids. So it's a shape identification issue that we can work on them with. Now, for number 36, 26% of the students chose B. Let's go back and look at that. B here ignores the two triangles. It just looks at these two shapes right here for whatever reason. And this could be a slight misconception, simply because they might not think the two triangles are part of the roof, right? Because this is a real world context. And so or part of the wall, they might think that's more of the roof rather than the wall. So maybe that could be it right there. Um, Honestly, if you see an entire shape, unless part of it is blacked out, shaded out, we need to do all of it. So we need to practice first decomposing each shape into different shapes and calculating. All right, so for that first one, we could do the two triangles and the square. That's what we did. You could do the three rectangles and the two triangles. That was that other option, right? That blue, the three rectangles and the two triangles. Okay. There's many options there. With number 36, the two rectangles plus the two triangles or the trapezoid and the rectangle. Now, obviously, this one is the one we did not do. That's a lot more work. But the point here is if you practice decomposing these shapes into multiple different shapes, it will just drive home that point that no matter how you do this, you will get the same answer. If you compose it into large shapes, into small shapes, into this rectangle, into this rectangle, that's the conceptual understanding we need our students to understand. It doesn't matter how you decompose it. And the best way to teach that is to just do it again and again with different iterations. If we want to increase the rigor, obviously we can remove the multiple choice. If I were working on this one right here, 36 with my students, I would probably just delete these, make them figure it out. Just because if they're close and they don't get an answer, sometimes they'll end up guessing the right one. It's just really raises the rigor when there's no possibility to get this number correct unless you get it absolutely correct. There's still a 25% chance that you could guess correct on 36. So we don't know how much that 47% actually knows it or guessed correctly. And then for number 12, what we could have done is we could have calculated the entire area, another option we didn't talk about, and then removed a section. So let's go back and take a look at that. I'll go over this with green. Okay, what we could have done is we could have taken this entire thing right here, right? And we could have said, you know what? That is if you rotated it, it's a trapezoid sitting on top of a rectangle. We could have calculated this trapezoid right here, could have calculated this rectangle right here, and then what we would have needed to do would we would have needed to take out that rectangle and that square and then take out that rectangle. So that's another way to do that, is just to add to that idea that you can even add pieces back in if is a missing piece and then just subtract it at the very end. For 7.9b, we are looking at reporting category 3. Didn't do much better. 37.5% overall mastery, circumference, and area of circles. Now, this one was extremely difficult, number 14, 31%, because take a look at what it's asking us to do. The circle has an area, and then it gives us the area. Which measurement is closest to the radius? Okay, so what do we know about the area of a circle? The area of a circle, if we look at our formula chart, pi r squared. But they're asking us for the radius, okay? Two different ways we can do this. One way, well, let's just substitute in what we know. We know that the area is 28.2 28.26. 28.26 equals pi. We're going to substitute in pi for 3.14 times r squared. Here's the problem. I'm looking for r. So I could, if I wanted to, I could solve for r. So if I'm comfortable solving for r in the 7th grade, what I could do is I can just say, well, 3.14, I'm going to divide both sides by 3.14, right? And this is where it's going to get tricky because we don't necessarily in 7th grade have the calculator. But if we just think, well, that's going to be close to 9, it actually does work out to be 9. You get 9 equals r squared, but without the calculator in 7th grade, students would have literally had to do this. So you see where that's problematic, but they could have done that, correct? Then you have this problem. Well, 9 is r squared. Well, that is an option, but that's not the correct answer. Because then I need to think what times itself makes 9, or I could take the square root of both sides. So r is 3. Now, that could work. Another perfectly legitimate option on this particular problem, since it has the 4 options, is the plug and play, or the estimation, right? So you just say 28.26 equals, and then start substituting. 3.14 times 3 squared. Okay, 3.14 times 6 squared. Now, here's the problem. If you write all these out, you should be able to see that only one of them is going to work, and I don't even have to do any math. Because once I start squaring the radius, look what I get here. Okay, times 9. That works. Times 36. 3.14 times 36, already too large. 3.14 times, look at that, 25. 25 times 3 something is going to be too large. And then 9 is 81, so that's already too large. So even if I just knew what it means to square the radius, and I looked at that next to 3.14, it's still going to only show me one possible answer. So that is where that came in. Then we get this circle on 25. It's a sprinkler. And I'm looking for the area. And then here's the challenge, right? Area, once again, is pi r squared. Sometimes they'll give us a circumference problem. This year they didn't for this particular standard, but they don't give us the radius. They give us the diameter. So students are going to make mistakes. They're going to use the diameter, but the radius is halfway, right? So that's 7. That's also 7. So area equals pi times 7 squared, which means we're looking at 3.14 times 49. And if I estimate this right, this is 3 times 50. Look, there's only one that's close, right? That's going to be D. All right, so for number 14, they had to find the radius when given the area, which means divided by 3.114, taking the square root. This is the first time for this particular standard, 7.9b, they've given us the area and asked us to find the radius. Typically, they'll give you the radius, you have to find the area, or like we saw on number 25, they'll give you the diameter. You still have to find the area, which means you have to cut the diameter in half. It's the first time this has been asked, so that is a problem really that gets into algebra and properties of equality and how to isolate a variable. So for more advanced students that are ready for that algebraic thinking, they can definitely do that. If not, I would recommend looking at this with my students with the number sense approach, looking at it this way, and just squaring the radius and seeing which of these could possibly get us to 28.26. That also works. For number 25, that's the traditional problem they give us. They ask us for the area and they give us the diameter rather than the radius. Now, what can we do as educators to better help our students? Well, we can use estimates for pi, like 3, and we can practice solving for radius given the area, right? And so we can start with more friendly numbers, right? So we could say, area is 27, And we can say, let's use 3 for pi, right? R squared, and then have them try to figure out what that R is. Take the decimals out first, then we can put the decimals in later once they get, the gist of what we're doing. Now, we can use the given radii answers to substitute into the formula for the area to solve. That's what we're talking about for number 14. And this didn't necessarily crop up this year, but a lot of times what we'll do is we'll be given the diameter and half the students will find the circumference rather than the area. So whenever we see a problem like that, if we've got the time, let's have them find both. Find the area and the circumference to practice differentiating, right? Because the circumference equals the pi times the diameter. So we're using obviously pi in both. And so that can sometimes confuse people. Um, some people might even think that they're the same because they think that r squared is the same as the diameter, and r squared is not the diameter. The diameter is 2r, not r squared. But even if we're not understanding how exponents work, students might think they're very similar. So we just need some extra practice there to differentiate between these two by finding both. Next, we are looking at 7.4a. This is in reporting category 2. It was tested twice. We only had 39% mastery. We're representing constant rates of change in all different representations here. So we've got two different graphs, but we're taking them from verbal descriptions. And so let's look at this first item here on the left. This is actually the second time it was tested. On the test, it was number 30, and it only had 29% correct. You see, it's a graphing item, which means students need to simply graph the correct linear equation. This is a 1-point problem. They either get the correct line or they don't. So all we have here are trail mix requires 1.5 cups of nut for every cup of dried fruit. So let's see this. I've got x-axis is going to be the fruit. So for every cup of fruit, let's just make a table of values here. For 1 cup of fruit, my y is going to be my amount of nuts, 1.5 cups. I'll just do decimals there. So then we can just simply add 1 and 1.5 to get a few different values here. And we can also say it goes through the origin, right? So if you have no cups of nuts, you have no dried fruit. So we can start with at 0, 0. And then let's just put some, we get an x value of 1, a y value cup of nuts at 1.5, 2 and 3, 3 and 4.5, 4 and 6. And then we're off the graph. So any of these 2 points would work. If the student selected any of these 2 points, it would create this line and they would get 1 point. As you can see, only 29% of students did that. Now, this one on the right was actually tested first. It's number 16. We got a little bit better, but that's because we're selecting between 4 graphs. So in a city, the average cost of electricity is 12 cents. So let me write that down, 12 cents per kilowatt hour. All right, 12 cents per kilowatt hour, and then which graph best represents this relationship. So they simply give us the rate, 12 cents per kilowatt hour. And take a look what we have on our x-axis. Let's make a table of values again. All right, so our x-axis is our kilowatt hours used, 1, 2, 3, 4, 5. So let's say we got 1 hour. Well, how much does it cost for 1 hour? 12 cents. But notice that they give us the cost in dollars. Okay, so I'm going to just put decimal here. So look at how small that's going to be. That slope is going to be very shallow if I move over 1x and only up 1.2, up 0.12. I can't find that, so I'm going to have to keep going until I can at least get close to 1. But look, I'm just going by 12s here. This is one option. Obviously, we could use our rate, and we could just go straight to where we need to, but I think the table of values is going to show, look, at 4, I'm a little bit under a half. And that's going to be difficult for me to visualize just because these, the y-axis here goes up to, count it to 12. But really, you can count up to 13 if you need to. And so getting all of these decimals, look, I'm at 6. I'm not even to a whole yet. 7. 0.84. Now I'm going to get close to 8. And then at 9, I'm going over. All right, so 8 times 12 is 96, 9 times 12 is 108, so using the decimals. So somewhere in between 8 and 9, my y value goes over 1. So let's look. It goes over 1 between, it looks like that might actually be it right there on A. Let's see, on A, it goes over 1 a little bit too late. So that goes over 1 at about 11 and 12. And then C and D are just way too steep. So this one is tricky. Our correct answer is A, but I do see why some students might get B if they start recognizing the pattern. We were a little bit better on that one. 49% of our students got that correct. So for number 16, that was the difficult part. The rate was given in cents. The y-axis was given in dollars. Right now, they did give it to us like this, 12 cents. But most of us, right, we start thinking of it like this. And so it's easy to conflate that with 12, and it's not 12, it's 0.12. So that was the difficult part. For 30, the rate was 1.5, right? So that was given to us in a mixed number. So either students could keep the mixed number, or they can convert that to a decimal. And then multiple points, like I said, could have been selected for that one. So what we need to do is we need to, first off, practice slightly adjusting the units when giving rates and graphing them. So give a rate of 0.5 miles per hour, and then show the y-axis in meters. That's going to help with this 16 right here. It needs to be the same conversion. We're not necessarily going feet to yards, but use decimals. Give a rate as a decimal, and then give the y-axis as a whole number, and help them kind of navigate how the decimal fits with that whole number. And then we should practice graphing old school first. Paper first, multiple points that all sit on the same line. Before we jump straight to this platform, if students can make a table of values and show them what happens if I graph those 2 points, what happens if I graph these 2 points, what happens if I graph these 2 points. This is a piece of conceptual understanding that students might still need cemented in their minds. Any 2 points along the line will form the same line. So when they get to the online platform, they can play around with dragging these dots anywhere and noticing that as long as they move the dots to any point along the line, the exact same line shows up. That's a piece of conceptual understanding that they might need help with. Next, we have 7.7a. You see we're getting closer to 40% there, 39.5%. We're representing linear relationships using, same thing, verbal descriptions, tables, graphs, equations. In this case, simplify into the form y equals mx plus b. All right, so we're spending a little bit of time with slope-intercept form. Now, we have number 18 and then number 15. So let's look at the one on the left first. Carson practices each day to prepare for an upcoming race. He starts the day by running 2 miles and then walking at a rate of 4 miles per hour. And then we need to find that representation here. Now, there's 3 correct answers. If we think about it logically, we've got 2 tables. We've got 2 equations. And then we've got 2 graphs. So it makes sense. And the correct answer is going to have one of each. So we'll need to just keep that in mind. Okay, so let's think about this. Okay, so he starts the day by running 2 miles. Okay, so let's make a table of values here. Okay, so running, walking. This is going to be kind of a convoluted way. This is the way a student might kind of pull it together if they're not really sure. Immediately had to go straight to the equation. Okay, for the hours, and then total. Okay, so he starts that 0 hour is not walking. Okay, he's got 2 miles run. He hasn't walked anything, so he's gone a total of 2 miles. Now, after he's done running the 2 miles, he walks at a rate of 4 miles an hour. So at 1 hour, that 2 is not changing, right? The walking is 4 miles. 2 and 4 make 6. At 2 hours, the running doesn't change. Now he's walked 8 miles, and that makes 10. At 3 hours, the running hasn't changed because he's not running again. He's now run 12 miles. That goes to 14. Okay, so this will help us. I made this big table of values, but we can actually use these two columns. You see they match up right here. Number of hours walked, I've got 1.6. Now, I didn't do 0.5s. So let's look at our whole numbers. 1.6, 1.6. Both of those are correct. But look at 2 hours. That means he's got 8 miles walked and then the 2 hours run. This says 10. This says 8. So this does not keep up with the 2 miles that he ran. Okay, so our first correct answer is this right here, that topmost table. Now, we can use this table of values, hours walked, and total number of miles. We can use these two right here. So we need, at when it's 0 hours walked, before he's even started walking, he's already gone 2 total miles. So that is our y-intercept right there. So we need that y-intercept right there. This has got 4, and that's the rate, and that's not going to work. So this is our correct answer, and it's simply because the y-intercept is correct. The y-intercept, what happens when you have 0 on the x-axis? The x-axis is labeled as number of hours walked, so before he's walked, what has he done? He's run 2 miles. Now, how do we put all this together into slope-intercept form? Well, when we're thinking y equals mx plus b, we need to know what these two letters stand for. This is our slope, or we can think of it as our rate. They give us our rate, 4 miles an hour. All right, so we can say y equals 4x, that per lets you know that we're dealing with a rate, plus our b is our y-intercept. What happens when x is 0? So before he started walking, what has he done? Well, he ran 2 miles, so we can get that 2 up there. Even though one is walking, one is running, the y is actually measuring the total number of miles, either walking or running. So now that is going to help us. And so it's the rightmost graph, right? That's going to get us our 3 correct answers. So that was number 18. That was actually the second item on this particular test. The first item on this test, that tested 7.7a, simply gives us a variable description. We need to turn it into a graph here. Okay, so which graph best represents a line where each value of x is, so I'm going to put equal, 3 more than 1/2 x, 1/2 the value of x. Okay, so if I were to flip this, let's just use the commutative property of addition, flip these two addends. Now I've got my slope-intercept form, y equals mx plus b. So my slope is half, and then my y-intercept is 3. All right, so that's going to be the easiest, is that y-intercept. Let's see if we can find graphs that have the y-intercept. Where does it cross the y-axis? This is a proportional graph. It goes to the origin, so that is not what we need. This goes through 3, so maybe. This goes through 3, and then this goes through 3. All right, so we have at least eliminated A. Now, we're looking at half. Okay, so what that means is when your rate is half, that equals the change in y over the change in x, right? So that means that's our rise over run. So that means we go up 1 over 2. So let's start up here. At 3, we should go up 1 and then over 2. So we should be at 2, 4. Obviously, that one doesn't work. Up 1 over 2, that works. Up 1 over 2. This one actually has a negative slope. So we could, once you get a little bit more comfortable with linear equations, anytime it's slanting down, it's a negative slope. That's a positive 1/2 x, so we could have eliminated that as well. So our answer here is going to be C. So for number 15, more students chose B than the correct answer. Now let's go back and look at B. 32% chose B. Now, why did they choose B? Well, because they're looking at that 3. So this does work for the y-intercept, and it is a positive slope. but it is not the right slope. So we can't spend all of our time when we're working with students and just identifying the y-intercept. We need to help them get, obviously we could have made a table of values, right? Now that we have our actual equation, we can substitute in 0 and 1, 2, 3, 4, 5 for x, plug those in, see what happens. But this is also a really quick way. It's just looking at the slope of rise over run, y over x. And without even doing any calculation, you can count 1 up 2 over to find that B doesn't work. So that's a strategy that we can work with our students that they'll continue to use in 8th grade and in Algebra 1. And then 24% chose A, y equals 1/2 x. So A has the correct slope. It just doesn't have the correct y-intercept. So we didn't put both of them together. And obviously the correct answer is going to be a little bit farther down after you work through the correct y-intercept or the correct slope. This one's got the correct y-intercept. And so that's definitely, look at that, 24%, 32%. The correct answer is only 30%. So a lot of guessing happening there. For number 18, we had to translate the verbal description. That the decimals kind of threw me off in the table of values. When I create a table of values, I don't naturally create decimals, but we didn't necessarily need the decimals because we had two numbers that we can look at. And with these two in my own convoluted table of values, right? We could have used the hours as one and the hours of two, and that was enough. That was all we needed. If I needed to, I can go back and look at the decimals, but as long as you've got a decent sized table of values, you can probably work around that. So what do we need to do here? We need to spend time exploring how the slope-intercept form of linear equation translates directly onto graph, right? We need to make sure that students know that if you get an equation in this form, you can tell several things about the graph, with regardless of what the numbers end up being, right? This is going to be your y-intercept. This is where it crosses the y-axis. If it's just this direct variation, y equals kx, right? We kind of switch the m to a k. That means the b is 0. That means it goes directly to the origin because b is 0. If x is 0, b is 0. 0, 0 makes the origin. And then we know some things about the m, our slope. If it's a decimal, it's going to be shallow. Positive decimal. If it's the larger it is, the steeper it's going to be. If it's a negative decimal, it's going to move down and be shallow. And if it's the the smaller it is, the greater away from 0 it is, then the steeper it's going to be. Like all of those things that we can explore with kids can help us start identifying graphs without even doing a lot of calculations. And then we can easily take these four iterations of linear equations, the table, the equation, the graph, the verbal description, take problems that give them to you like that, turn them into a matching game to really stamp their interchangeability, right? Make it a game in which, like a Go Fish, right, in which they're trying to get a book of four. There's various ways to do this, but students really need some extra work with those four iterations of linear equations. Next, 7.11a. We barely get to 40% here, reporting category 2. We're modeling and solving one variable two-step equations and inequalities. All right, so in this case, we're solving both. Sometimes we end up modeling. So number 10 is a 2-point problem. We got 35% full credit, 35% partial credit. So let's look at this first one. Negative 3x plus 9 less than 18. What we're going to do is we're going to pretend like that's an equal sign. We're just going to use the properties of equality here, right, to kind of isolate that x. So if I subtract 9 from both sides, I get negative 3x is less than 9. Now here's the problem. I need to divide by negative 3 to get that x isolated. When you multiply or divide by negative, you end up flipping the equality. That's just one of the mathematical rules. And if students miss that, then they're going to obviously get this one wrong. Because as you can see, x is less than negative 3, x is greater than negative 3 are both answer choices here. And if the students that got partial credit, my guess is that they might have missed that first one. Now, to double check our work, right? Unless it's greater than or negative, let's just do this. And this, I would encourage students to do this, right? If here's my number line, here's my -3. I think x is greater than 3 is going to work, right? So let's do that in a different color. Let's do a -1. -1 is greater than 3. And then let's also try x is less than -3, a -5. Plug them in. See which one works. So I'll try the one that I think works. -1 plus 9 less than 18. Okay, so -3 and 1 is going to be 3 plus 9 less than 18. 12 is less than 18. So if students are stuck, they can't remember whether the negative changes it, have them, pick a number that falls into that category. In this case, I found a number that was greater than -3, and then it works. Now let's try that -5. So let's do -3, -5, plus 9 less than 18. And we've got 15 plus 9. It's going to be 24 is not less than 18, so that doesn't work. Okay, now this other one, 4x minus 24, is going to be, and I'm going to do that right up here, 4x minus 24. The x is already positive, so we don't have to worry about that, right? And that's going to be 24, not 2x. So let's add 24 to both sides. And let's just get 4x is greater than 36, divide by 4. And we've got x is greater than 9. Okay, now it wouldn't hurt to go ahead and double check this as well. So let's pick something greater than 9. Let's go 10. So let's say we've got 4 times 10 minus 24 is greater than 12. All right, so that's 40 minus 24 greater than 12. That's 16. It's barely, but it is greater than 12. All right, so all of that works. So that's a 2-point problem, 1 point for each correct answer. Now, for number 34, we only got 27%. So we actually did better on number 10, the drag and drop, than we did on number 24. Let's see what we did on this one. So I've got 4 plus 1/2 x minus 8 equals 12. Now, this seems like it's a little bit more straightforward, but we do have to combine like terms. I cannot combine 4 and 1/2 x. Those are different terms. What I can combine are these two. So I can think about it as 4 minus 8 plus 1/2 x, right? I'm just going to take the commutative property. I'm going to flip the order there. So what's 4 minus 8? That's -4 plus 1/2 x equals 12. So that first step is to combine like terms. Let's do the rest over here. Now let's add 4 to both sides. And I'm going to get 1/2 x equals 16. Now, getting rid of that 1/2 is going to be a little bit difficult. You see, if I divide by 2, 16 divided by 2 is going to be 8. But 1/2 divided by 2 gets you 1/4, right? We need to think reciprocal. So what's the opposite of all of that? And that's just going to be multiplying by 2, right? The reciprocal of 1/2 is 2 over 1, or 2. So if I multiply both sides by 2, what I end up getting is 1/2 times 2x, and then I've got 16, and then let's do that times 2. So that cancels out, and I get x equals 16 times 2, or 32. Now, if we want, we can plug that back in, but that is going to work. So our answer there is D, but you see we only get 27%, just a hair above guessing. So for number 10, right, students had to know what happens to inequality when you multiply or divide by a negative number. That's the big key learning, and you can almost guarantee that you're going to get a problem like that on each 7th grade STAAR test. They're going to have to isolate a variable. It's going to take 1 or 2 steps, but there's going to be an inequality, and it's going to have a negative coefficient, and you're going to have to multiply or divide to get rid of it. Students just need practice knowing what happens when you multiply or divide a negative number. Now look, for 34, the second one, B, C, and D were all 27%. So let's just think about that for a second. B, 27, 27, 27, 19. So there's no guarantee that anyone that got D actually knew what they were doing. This is 100% indicative that there was a lot of guessing going on in this particular item. That was extremely difficult for students. They had to do two things, and it's kind of hard to tell which one knocked them off because there's not one incorrect answer that kind of rises up as a misconception. They had to combine like terms. They had to find the 4 and the -8, which were not next to each other in the original equation, right? We had to use the commutative property to kind of rearrange things. And then we had to multiply by 2 to get rid of that 1/2 to isolate the variable. And a lot of times your coefficients are whole numbers, and students are used to dividing by that coefficient to find the correct answer. So having them work with what happens if it's a 1/2 x, a 1/4 x, that might mess them up, or even a 0.5x. Could they, figure out what to do there? So one way that we can work with this is like I did, check your work with substitution, verify the inequality does in fact change because it's kind of counterintuitive. It's not the most obvious thing there. So use substitution and just select some values either above or below whatever you think the inequality comes out to, just to verify your work. And then we need to practice combining like terms, constants and variables. And there's no guarantee that you might not get this. 4x plus 3 minus 2x is greater than something, right? 16. Right, so we need to identify like terms to combine first before we start solving. Whether it be an inequality or an equation, the like terms, and then the other challenge is going to be what happens if you end up with a fraction or a decimal as a coefficient. That's going to be a challenge as well. Next, for 7.6i in reporting category 1, we are determining experimental and theoretical probabilities using data and sample spaces. We had 44% overall mastery. It was tested twice. You see we did a little bit worse on number 13 than we did on number 31. So let's take a look at 13. So we got two different spinners, and so this lets us know we are dealing with a compound probability because we need something to land on a 2 on spinner X, and then on spinner Y, it needs to be on blue. So we need two different simple events to come in sequence to make this compound event. Now, we've got choices. If students aren't really sure as to how to solve this, we could just make a sample space. We can think, well, okay, if I spin a 1 on the X, what are the possibilities? I could do 1R, 1G, and then 1B. Then I can simply repeat that with 2. 2R, 2G, 2B. Now that's the one I want, 2 in blue. But if I'm going to have to show my answer as a fraction, I'm going to need to complete this in a nice organized way so I can keep track. And as you can see, I've got them all right here. So there are 12 possibilities. There's only one possible answer, so that's going to be my fraction 1/12. Now, for those of us that know, you can actually, when you're doing compound probabilities like this, you can actually multiply the fractions. So what is my fraction of getting the 2 that I need on spinner X? Well, 1 out of 4 possible choices. What is the fraction that represents the chances of me getting a blue on spinner Y? Well, 1 out of 3 possible choices. 1/4 times 1/3 when we multiply fractions. You just multiply straight across and you get 1/12. So that's that one. But as you can see, 33%. That's not far above guessing. And then 55% here, got 31, so a little bit better. So we just need to say, they already give us the numbers here, so it's a simple event, even though we are drawing two of these cards, we're doing it at the exact same time, red or orange. So red or orange are 17, right? All together. That's red or blue. Let's get red or orange. That's going to be 20. And you don't have to add. They give it to you 40. So 20 out of 40, we simply need to simplify that, and we're going to get 1/2. Okay, so that seemed to be a little bit easier. Next, we're looking at 7.6i. This is in reporting category 1. We're dealing with experimental and theoretical probabilities here to both simple and compound events. So number 13, as you can see, we struggled with a little bit more. It is a compound event because we've got spinner X that we need to land on 2. We have spinner Y that we need to land on blue. So the rules kind of change when we are dealing with compound events. And we need students to know that you don't just add the options, right? Now, if we wanted to just add the options, there are 2 different choices, and there's 7 different possibilities, and obviously we've got that as one of our answer choices, but that's not how compound events work. If we were to make a sample space here, let's say if I spun a 1 on spinner X, what could I get on spinner Y? I could do R, I could do a green, and I could do a blue. Those are all the possibilities I have with spinning a 1. So let's repeat it with a 2. Red, green, blue. That's the one I want. So let's keep going to figure out what my denominator is going to be because I need to represent this with a fraction. Green, blue, 4, red, green, blue. All right, so I've got a 3 by 4 array. That means there are 12 possibilities. Only one of them is the one I want, so that is my answer. Now, if students know about compound events, they also know that you can represent each of these simple events, because a compound event is just a string of simple events put together, each of these simple events with a fraction. So what are the probabilities that I would get a 2 on the x? Well, that's 1 out of 4 possibilities. And a blue on the spinner y, that is going to be 1 out of 3. When you get these, you can multiply. What is 1/4 times 1/3? You can get straight to your answer, 1/12. So, as you can see, only 33%, which means that's not far above guessing. That is not going to be a good answer distribution there. 55 is a little bit simpler because we are dealing with this simple probability. We've got all of these colors with a deck of cards, and we're pulling something 40 times, so that's going to be our denominator. So experimental probability, right? We're looking for red or orange. Well, red is 9. Orange is 13. It could be either one of these, so I'm going to add these two. So that equals 22 over 40, which equals 11 over 20. So that simple probability, as you can see, was a lot easier for our students to understand. It was that compound that gave us challenges. So, like we just said, the simple probability was a lot easier than the compound probability. Now, for number 13, more students chose C, let's go back and look, than the correct answer. And that's the one that we originally called out. We had 41% choose C. We only had 33% choose the correct answer. So, students were conflating the compound event and the simple event. If that were a simple event, yes, you just add up the 2, right? There's your 2 and there's your 7, and you're good to go. But that's not how a compound event works. So part of the challenge is to recognize when something is simple, when something is compound. And so that identification, not even solving, just identifying is going to be a good practice step for students. Identify first and then verbally describe the process. Rather than just doing the work and getting graded correct or incorrect, it's more challenging to have to describe the steps in order. And so that could be the challenge for students. Give them a situation, a experimental probability or theoretical probability, and have them identify and explain with a partner. Is this simple or compound, and what do I need to do to solve? And we can use sample spaces like I did to show that first answer, rather than going straight to the hack, because this is a hack. and it's a shortcut, and it works. But if they don't know why, go straight to that sample space. Let them slowly develop that sample space, and then this has something to land on when you're saying, and this is a more efficient way to do it, because now they have a frame of reference for understanding why you just multiply the two fractions. Next, we're looking at 7.3b. This is in reporting category 2, slightly better, 45% overall mastery. And we are just operations, addition, subtraction, multiplication, and division. And the sky is the limit here because it's rational numbers apply and extend. All right, so let's start with number 5. That was the more challenging one. So family records the amount of milk used for 4 days. And then for some strange reason, this family decides they want to record it in fractions that have different denominators. Not sure why they would do that. So how much milk in gallons does the family have left after they started with 1 gallon of milk? So that's the challenge here for students. Okay, I'm going to draw a strip diagram, and I've got 1 gallon of milk. That is my total, or my whole. Now you can see here, I've got chunks or sections, okay? So I've got 3/16. I'm just going to have to extend it down there. I have 3/8. I've got 1/8. I've got 1/4. This is what I'm looking for. That missing piece. How much did they have left? So if you can represent it in a strip diagram, you can see, all right, I need to add these 4 sections, subtract it from 1. All right, so let's do that. We need to find a common denominator. And 4 goes into 8, and 4 and 8 both go into 16. So let's change everything into 16ths. Okay, so 3/8. We're just going to multiply by 2. We're going to get 6/16. 1/8. We're going to double it as well. We're going to get 2/16. Now the fourths, we need to multiply by 4s. And we're going to get 4/16. So I've got 3/16 here to begin with. And then I've got 6/16. So let me just add 3 plus 6 plus the 2 and 4. And that's all going to be 16ths. That's 9. And that's going to be 6. So that ends up being 15/16, which is an answer choice. But it doesn't ask how much milk did they use. They asked how much milk did the family have left. So if I subtract 1 minus 15/16, we can change that 1 into 16/16. Or we can just use number sense to say, all right, we're 1/16 away. So that's our answer, D. Now for number 24, same type of idea. We've got 2 different steps here, okay? Fernando recorded the weather for 90 days. That's our total. So let's draw a strip diagram. Let's draw that up there. So sunny for half the days. Okay, so I've got chunks here. So I can do half is sunny. And then I've got 1/3 of it rained. And then I've got the rest is snowed. So I don't know what the fraction is. But look at so I'm looking for how many days it snowed, but look, I need to not only find the fraction, but then I need to convert that into actual days. Okay? So let's do 1/2 plus 1/3. So let's just multiply each fraction by the other denominator to get equivalent fractions with denominators of 6. Okay, so 3/6, 2/6. Add those together, what do you get? 5/6. All right, so if these two are 5/6, and this 90 days equals the 1 whole, then that's going to get 1/6. So that's the first step. If we get that, that doesn't necessarily get us an incorrect answer we can choose. We still have to turn that into days. But now we need to understand, well, what happens if we take 1/6 of 90 days? Right? Well, 1/6 of 90, you can multiply or you can divide by 6. Either way, you're going to end up with 90/6, right? And now we need to do a little bit of division. And so that is going to be 15. Okay, 6 goes into 90 15 times. And so that is our answer. And that does make sense. That's the smallest number possible. 1/6 is going to be a lot smaller. Another way we could have solved this would have been like this. You could have said, well, what's 1/2 of 90? 1/2 of 90 is 45. You could have said, what's 1/3 of 90? Well, divide 90 into 3 equal parts, 30, 60, 90, so 30. Okay, so if I've got 40 and 30, 45 and 30, that's 75. So 75 subtracted from 90 is going to get you your 15. So two different methods we could use to solve this problem. So for number 5, students had to find the partial sum and then subtract from the whole. That was the challenge, was finding the 15/16ths, and then they still had to subtract that from the whole, rather than just finding the 15/16ths and then choosing that. Okay. Now, we had 27% of our students choose B. 2/9. Where are we going to get ninths? Well, take a look at what we can do. And I'll do it up here. 3/16 plus 3/8 plus 1/8 plus 1/4. Okay, so let's say students knew you needed to add, but they're still in 7th grade and they think I'm just going to add straight across. Well, there are several students that thought that was a choice. So let's just add. 4 and 16 get you 20. 8 and 8 get you 16. So 20 and 16 get you 36. 3, 6, 7, 8. 8 out of 36. And then my teacher said, oh, I always need to simplify. Divide both by 4. And guess what I get? 2/9. We still have 27% of our students choose that. And only 35%, remember, choose the correct answer. So not that far behind. And then for number 24, 23% of our students chose B, which is just 30. So they just said 3 sections, 30, 30, 30. They kind of ignored the fractions and just did 30, 30, 30. So we had 23% of our students do that. So that was kind of a misconception, because that was the next highest incorrect answer. So what can we do to help students? As you can see, how did I solve both of these? Strip diagram. That's probably the best tool that they can use to solve these problems. And really, the idea here is, how do I organize my thinking to identify the operations I need? I need to add and then subtract. I need to add and then multiply or divide. So that strip diagram really helps them get an understanding of the quantities and relationships in the problem, so then they can start to solve. And then we've got to continue, even though this is something that started back in 5th grade, we need to continue working with how to add fractions or multiply fractions with different denominators and finding the least common denominator. In this case, right, we had the denominator of 4 and 8 and 16. So rather than simply just adding 2 different fractions, we need to add multiple fractions that have different denominators so they can practice getting all 3 or possibly 4 different denominators into the same denominator for addition. 7.6G, reporting category 4. We are looking at 46% overall mastery. We are solving data problems. In this case, we've got a circle graph and we've got a dot plot. So remember, we're solving data problems. We're not necessarily identifying the information, but we're doing some calculations with this data. Neither or are we summarizing data. That's more of a 6th grade trend, is summarizing data. Now we're solving data. So I've got a 33% on number 11. So I've got 150 employees. I got my percentages here. How many more people? All right, so I need to compare car. So if I were to do a strip diagram, how many more people did a car than a bicycle? My question is, what's the difference? Comparing the two. All right, car was 38%, but 38% of what? I'm not going to subtract percentages. 38% of your 150. Okay, so I need to figure out what is 38% of 150. So I'm just going to multiply my 150 by 0.38. So you see how we're getting difficult already, because 7th grade we still can't use a calculator. So I've got 40, got 120. Okay. So now I've got 0, I've got 15, I've got 3, I've got 4. All right, so I've got to do this calculation. 57, 2 digits behind the decimal. So this is 57 people, which is an answer choice. Now I need to figure out bicycle, but there's no percentage by bicycle. Okay, so what I need to do is I need to add up the percentages and subtract from 100, knowing that 100 is my whole. So what is 32 and 38 and 20? That's 10. It's 90. All right, so this is 10%. But that's a percent. So now I need to take 10% of 150. Now, if you remember what happens when you take 10% of 150, right? You could just move the decimal in, right? You can just do this. It's going to be a whole bunch of zeros. This is going to be repeated, right? So what you end up doing is you move the decimal in one from 150 to 15. So now I've got 57 people rode a bike. I've got 15 people rode a 57 people rode a car, 15 people rode a bike. Now I can subtract these two. 57 minus 15, and that's going to be 42 is our correct answer. 33% correct. That was a lot of different calculations needed to get to that correct answer, so I see why that's a challenge. Next, we've got number 21, and we've got this dot plot here. There are two correct answers, and so we need to find both of them here. So exactly 9% of the turns were 2 points. Ooh, 9% is kind of a strange percent. Well, look, how many do I have here on 2? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, I actually have 9 people there. But 9 does not mean 9% unless it's out of 100. So that's a misconception there. Let's go ahead and figure out what we've got here. I've got 4, I've got 3, and I've got 1, 2, 3, 4, 5, 6. I've got 3, and then I've got 5. And then the total was 30. But 9 out of 30 is not 9%. 9 out of 100 makes 9%. Okay, so exactly 1/6 of the turns were 5 points. Okay, 5 points is, let's see, that's going to be, let's put it over here, 5 out of 30. Let's see, divided by 5 to simplify. And I've got 1/6. Okay, option 2 is correct. Half the turns were 3 points or more. Well, let me just draw a line here. And does it look like that's going to be exactly half, 3 points or more? Well, let's see. 6 and 3 is 9, plus 5 is, that's 14 out of 30. So close. If it was one more, it would be correct. 15 out of 30 is exactly half. Exactly 1/10 of the turns are 1 point or fewer. So that's going to be 7 out of 30. That does not simplify to 1/10. 3 out of 30 would simplify to 1/10. So if you just did the 3, that would simplify, but you had to do the 3 and the 0 because it's 1 point or fewer. So it's not this one, so it should be that last one. 50% or 2 or 3 points. 2 and 3, that makes 15 out of 30. So yeah, we're good. So those are our two answers. We had 34% get full credit, both of those items. Half the students got at least one of those correct. We don't know which one. We don't get any data on the individual answer choices, so we don't know which one of these was a little bit easier for them to access. So overall, that ended up being, we get half credit on this, so that ended up being about 59% correct. So we did pretty good on 21. It was the number 11 that really threw us. So almost as many students on number 11 chose A, the total bike records, and B, the difference in percentages as the correct answer. So 29 for A and 28 for B. Let's go back and look. 29%, 28%. How do we get 15, right? So A, 15 was uh, the total bike riders, right? That 10% of 150 is that 15, okay? And then some people just did 28. That's the difference in percentages, the 38 minus the 10. So we had a lot of uh, misconceptions here, a lot of guessing, and partial attempts. With an equal distribution of these two, I understand how you can get 15 and 28. So there were some partial attempts at this problem, but it probably was a little bit too difficult, and students just kind of guessed. And then having to add that 150 employees and take your percentages from the 150 rather than just giving the numbers straight in the circle graph, that added an extra step, especially because it wasn't out of 100. And then for 21, what they had to do is find the fraction and percent of whole to successfully read the data. But once they realized it was out of 30 and they just took fraction of the whole or percent of the whole, they were able to access that. So for circle graphs, I would say if I were working with students, I would do something like this. I would use these percentages, but maybe start with something easy. Start with 100, okay? So that the percentages actually represented the actual number. So they get how to add or subtract or do what operation you want, and then change that total. Talk to them about what if there were 200 people, that all the numbers get doubled. 300 people, all the numbers get tripled. If there are only 50 people, then all your percentages get halved, right? So they start with some easy numbers of how they could take these percentages and they could apply them to different wholes that are not 100. So I would almost do it in 2 steps. And then remember, in dot plots and bar graphs, we're about finding a fraction percent of the data. We're about doing calculations. We're not simply reading the graph or summarizing it with mean, median, mode. We're doing some type of calculation. So we need to make sure our students are familiar with that, because in 6th grade, they spend a lot of time with summarizing categorical and numerical data with mean, median, mode, and all of that. For 7.4D, we're doing a little bit better, 47% overall mastery. We're solving problems involving ratios, rates, and percents. Now, we have the cost of groceries on number 20 here was $210, and we used 25% off. So we need to figure out what is the final cost after the coupon was used. So we've got a few different options here. If we want to look at it as a strip diagram here, so here's $210. Here's the cost of groceries. That's my total. And then we got 25% off. So if I wanted to break this up into two different parts, right? So I could say there's my 25%. That's what's going away. And then what's left is 75%. So if I wanted to, I can calculate 25% of 210 and then subtract that from 210. Or I can save it to just one step and just realize that if there's 25% off, that means I'm paying 75% of the price. I just want to multiply 210 by 75% or 0.75. And that will give me the exact same answer. So let's do that. All right, so that's going to be 0, that's going to be 7, that's going to be 14. So it looks like I'm going to have 157.50 as my cost after the coupon was used, and that is my answer B. Now, only 41% of our students were able to select that, so that was a little bit difficult. Number 37 was a inline choice, so it's a 2-point problem, but you notice we have a ratio, but look at this, blue to yellow to green. So let's write that, I'm going to write that right here. Blue to yellow to green is 4 to 3 to 1. So this is the first time that we've seen a 3-part ratio. Typically, it's a 2-part ratio. And what we need to do is we need to find 24 yellow gumballs. Okay, so I'm just going to kind of dot this. And this goes up to 24, okay? This is basically acting like a table of values. Well, if I'm counting by threes, right? 6, 9, 12, 15, 18, 21. All right. So really, I just had to multiply by 8, right? That's 1, 2, 3, 4, 5, 6, 7, 8. My eighth one. Okay, so then I can just extend this and I can just multiply each of these times 8. 32 times 8. I can just skip all of the multiples in between. All right, so this is what I'm left with. There are blank blue gumballs. You see my answer choice is 3, 8, 32, and 40. My answer is 32. And the machine contains a total of blank. Okay, so now I need to take the 32, the 24, the 8, and add them up. 8, 24 make 32, so if you double 32, you're going to get your 64. So that's how you got full credit there. 37% got full credit, 32% got partial credit. Not sure which of these two answers was easier for them. We don't get data on specific answer choices. So for number 20, we had 26% of our students choose A. Let's go back and look at this. So 26% chose A, which 5250, that's the 25%. That's the discount. Okay? So that's how much they had off. So they did the 210 times 25. They just didn't take that away from 210. So we had a decent chunk of students do that. And then 29% of our students chose C. Now, this is 29%, and the correct was only 41%, so not that far off. I can, understand this A because we are doing the 210 times 0.25. We just didn't subtract it. The 29% that chose C, it's 210 minus 25. I mean, that didn't even make sense. Why would we subtract 25? If we were going to do anything, we would subtract 0.25 because that's the decimal. So we've got a sizable chunk of students, this 29% here, that are still confused as to how even percents and decimals work, let alone percent off. So that's a misconception we need to think about. And then for the first time, students were tested with a ratio given in three parts, that number 37, that 4 to 3 to 1. That might have thrown them off. Now, some might have just assumed that if it's a ratio in three parts, it works like a regular ratio in two parts, and that is correct. So some students are able to push through that, but that was something in which you never want your students to be surprised when they're taking a STAAR test. There should not be a problem that surprises them. So look at this standard here. This standard includes many breakouts here. We have to solve problems. It might be ratios, it might be rates, it might be percents. We might have a percent increase. We might have a percent decrease. And we're going to include financial literacy problems. That's a lot of breakouts or substandards. So this is a standard that looks different almost every time you look at it because what we didn't get was a percent increase or decrease. That was tested in 2023, right? So we had percent off, but not necessarily, what is 150% increase of this or something like that. So this is a difficult standard that takes a lot of time. Students definitely, if they can really come to solidify their understanding of percent as a ratio per 100, go back to that foundational vocabulary, percent per 100, because a cent is 1/100th, right, per 100. That's going to help build their schema and understand what a percent increase, percent decrease, and understand that 100 is kind of that magic number when we're dealing with percents, and that will help them, especially with this particular answer selection, knowing that you don't just take 210 and then subtract 25, because that's not 25. It's 25%, which means 25 out of 100. And then we need to work with ratios given in 3, 4, or even 5 parts to increase their stamina, right? So there's nothing that says that we can't see a ratio that's to this. Let's just come up with 5 different colors of marbles, right? 5 red to 3 black to 4 green to 5 yellow to 8 orange. And then ask them questions off of that, right? If there's 25 yellow, how many green are there? If there's 24 blue, how many orange are there? Once they figure out how that works, it doesn't matter whether you give them 5 ratios, in a ratio in 5 parts, 2 parts, 3 parts. Next, we're looking at 7.9a, where 52% mastery. This is volume of various three-dimensional objects. In this particular case, we are looking for a triangular pyramid. Now, I always recommend draw some type of visual just to kind of ground what we're doing and also to help us make sure we are, selecting the right formula. So first, after we draw a triangular pyramid, we should always pull out the formula that's on the formula chart. Volume equals 1/3 base times height. Now, let's see what they have. The area of the base. Okay, so they are going to give you the area of the base. That's that bottom triangle. And they give it to you as 60 square inches. The height. Okay, so I've kind of drawn mine as a slant here. So I'm going to do my height as 13. That's my H. And we're just looking for the volume. Okay, well, I mean, that's filling in both of those numbers right there. So volume equals 1/3. Let's substitute in 60 for the base. Let's substitute 13 for the height. I'm going to go ahead and multiply 1/3 by 60 because that's the same as dividing 60 by 3. So that's going to be 20, right? Those two become 20. 20 times 13. Let's say 2 times 13 is 26. And then you add that 0 because I'm multiplying by a power of 10. And there we go, 260 cubic inches. So seems like it's pretty straightforward, but we only got 52% of our students that got that correct. Both the base and the height were given. They simply had to select the correct formula, and that may or may not have been a challenge for the students because look at the way the problem was written. Triangular pyramid. If you're just reading really fast, even though it says pyramid 1, 2, 3 times, we typically deal with triangular prisms, not triangular pyramids. So that might have thrown us off, and that's that's going to be a slightly different formula. So 29% of our students got caught up on that. They chose C incorrectly using the formula for the volume of a prism or a cylinder. Volume equals base times height. So 29% chose just your basic triangular prism formula. V equals BH. They just didn't cut it in third. They did they thought the problem was 60 times 13. That's going to be that should be your first red flag. This problem is way too easy. You're just multiplying two numbers, and 29% of our students kind of fell for that. So drawing a representation, even though drawing a triangular prism pyramid is not the easiest thing in the world, help students select the correct formula. This is a slow down and read problem to help them correctly select the formula that they need. But honestly, after that, it's substitution and multiplication. Next, we are comparing two groups of numeric data with dot plots or box plots, and we've got 53.5%. Now, this is the standard in which, in 7th grade, we are looking at summarizing this type of data. And so let's look at 17. We've got 48% correct, so let's just go ahead and think about what they're going to ask us to compare. We've got range, interquartile range, mean, and interquartile range. Okay, so let's just find what we can. Range is going to be, I'll just make that as R, the greatest minus the smallest, right? So I'm looking at 125 minus 70. And so that is going to equal 55. Whereas my range, let's put that up here. Range for sales teams Y is going to be 130 minus 65. That's going to be 65. A little bit larger. All right. I'm also going to need the IQR. Okay, the interquartile range is the difference between the first and third quartiles. It's the edges of the box. Box is really what it is. So that in sales team X, it's 90 minus 75, 15. And then we've got my IQR right here. I've got 105 minus 75. All right, so that is going to equal 30. All right, so I've got my range, I've got my IQR. Mean, I can't solve for the mean. I don't actually have numbers here. I have the summaries of the numbers. I could find the mean of this problem over here because I can calculate how many times each number shows up, but I can't calculate the mean. So it's not that one. I don't know if there's a thousand numbers in each of these sales teams or there's 10 and they divided it. So I can't calculate the mean. All right, so the range for sales team X, which is 55, is $10 more than sales team Y. No, it is $10 less. So that's not going to work. The interquartile range for sales teams X. Okay, so sales team X is 15 equals half interquartile range for sales teams Y. Yeah, 15 does equal half of 30. Okay, that looks good. Already said C doesn't work. Let's check D. Interquartile range of sales teams X, 15 is twice. Okay, so that's just the opposite, the inverse there, and that doesn't work. All right, so my answer is B on number 17. Now, let's look over here. We've got a dot plot, but before we start doing all kinds of stuff to it, let's look at our answers. What are they going to want us to look at? We're looking for distributions are symmetric, symmetric, not symmetric. Okay, so we're just looking at symmetric or not symmetric. And if we don't know what these words mean, we're in a lot of trouble here because everything revolves around understanding what is symmetric. Well, we've been dealing with symmetry since fourth grade. Symmetry, right, is when you've got a shape. So let me just draw a random shape here. Okay, so this shape has got one line of symmetry. It's symmetric right down that middle because you can fold in half and there's no overlap on either side. So same thing with these dot plots. Can you fold the dot plot in half and will be even on both sides? So if I were to kind of draw this right here, right above each of the lines there, that is not symmetric. But if I were to look at my men's shoes, take a look. Kind of go like this, up, over, down, very much. That is symmetric. So that's it. That's all I'm looking for. I'm looking for the answer that says the men's shoes is symmetric right here, but the distribution of the women's shoes is not. So there's my answer, B. And A, C, and D are just variations of the men or the women's being symmetric or not symmetric. So 59%. So we got almost 60% on that. So really, it's number 17 that kind of threw us off. So we had to be familiar with 17 range, IQR, and mean. But look at 31% of students actually chose C, the one that I immediately got rid of. How did 31% of our students choose C? Well, look, the mean for sales team X is $5 less. What if we replace this with median? What if students got confused with mean and median? Could we say the median of sales teams X? Well, here's the median right here, and guess what? It is $5 less. So the calculation is correct. That simply is the median rather than the mean. So that is a very good distractor for our students. They got 31% of them off track. And really, the only term that students had to know for number 32 was symmetric. So data problems are a lot more about vocabulary than calculation. We had to do a little bit of calculation, but it's basis subtraction on number 17. Really was understanding what the vocabulary terms mean, including confusing mean and median. And then students probably need to help with this word mean because we don't use it an awful lot. And sometimes we won't even call it the mean, we'll call it the average. So probably it would be good for them to really maybe even just do a real quick activity, a table sort, to where they're trying to figure out which data representations could we get a mean from and which data representations could we not. Like you would put a dot plot or a table or a list. You can get that in one section of I can get a mean from this, whereas you could not get a mean from a box plot or a histogram, right? And then just have them talk about why they can or cannot get a mean from a data set. That would help them with future problems. For 7.6H, we are in reporting category 1. We've got 54% overall mastery. And take a look at this. We've got 11%. 11% get full credit. That means you get all 3 points correct. And number 29, they did really well with. But it's number 6 that really, really kind of messed them up. They're making qualitative and quantitative predictions from simple experiments. So let's take a look at this. Basic types of books, a table, and we've got this very first sentence right down there. The student is more than twice as likely to prefer blank as to prefer blank. Okay, more than twice as likely. That is the key right there. This is the word or the phrase that probably tripped up a lot of students. Because if I'm just looking at twice as likely, I'm saying 9 and 18. Okay, so I'm going to put nonfiction down here because that's 9. Nonfiction, that's my 9. But my guess, we don't have individual data on these answer selections, is that a lot of students messed this up and they got, look how many people got 51%. That means they got 2 out of 3. They probably messed up this one right here. More than twice as likely. Well, if I were to put my 18 right there, that's not more than twice as likely. That is twice as likely. The only thing that I can do that's more than twice as likely is action. So these are the only numbers that fit. If I pick a larger number, there's nothing that's more than twice as large. But it's that more than that I think really tripped them up. And the student is equally likely to prefer action, right? So we had to take my action as prefer nonfiction or. So we're thinking 24 equals 9 plus, and then what's that missing number? That's going to be my fantasy, 15. I'm thinking that was pretty straightforward for the kids. My guess here is that it's this one. A lot of students probably didn't put action. They probably put that biography because that was twice as likely. They just missed the more than. For 29, a little bit more straightforward. So 200 students, and we've got a lot of them choosing dog, rabbit, cat, and fish come, after that. Student equally likely to prefer any of the types of pet? No. Dog is the most popular. 5 times as likely to prefer a fish as to prefer a rabbit? No. 5 more, right? But not 5 times as a fish than a rabbit. It's 5 more. That times is throwing them off. Student is less likely to prefer a fish than any other. No, fish is low, but rabbit is lower. I mean, look at this. Students more likely to prefer a dog than for any other type of pet. That's about as simple as you can get. Now, 29% of our students still did not get that correct, but 71% is fantastic. So for number 6, the key term that was most likely overlooked, like I said, is more than. And for 29, it's about as easy as you can get on a STAAR test. You're not doing any calculation. You're just looking and saying, wow, 110 is larger than every other number. That's a comparison problem. And they need to be prepared for that, even though a lot of times we over-prepare them because that seems to be pretty simple. So we need to remind our students that when we're dealing with experiments, predictions, right, either theoretical or experimental probability, anything like that, it's all about reading. And that's going to be a little bit more important than actual calculation because there's not that many complex calculations we could do out of predictions and experiment other than 5 times as much, half as much, but we need to read to make sure we understand what we're trying to compare. And then we need to show them how the most obvious wrong answer was available, like biography, to trip them up. They immediately saw that twice as likely they saw 9 and 18. They're stacked right next to each other. So visually, it's easy to compare those two, and that was done to probably trip them up.